In this video, we're going to be going through the practice questions that go along with quadrants and planes, and we'll start with question number 1. If point A has a non-zero x-coordinate and a non-zero y-coordinate, and the coordinates have different signs, then point A must be located in which of the 4 quadrants labeled below? So we can remind ourselves the standard is to label each of the quadrants in order in counterclockwise 1 through 4. So these are our 4 quadrants. So we have some important information in this first sentence. It tells us that point A has a non-zero x-coordinate and a non-zero y-coordinate. We have something other than a value of 0 for x and 0 for y. And now we are also told that the coordinates, we're talking about the x-coordinate and the y-coordinate, have different sign values. When we know that we'll just write this in an ordered pair form where we list x value then y value. The different options that we could have, x could be positive and the y value could be negative. That's the different sign values. Or x could be negative and y could be positive. These are our 2 options given this restriction on their signs. So in this case, where we have a positive x value is going to be, here we have a positive x value, but we also have a positive y value. In the second quadrant, we have a negative x value and a positive y value. In the third quadrant, we have a negative x value and a negative y value. And in the fourth quadrant, anywhere you have a point, you have a positive x value and a negative y value. And you could just use test points if you cannot see that. But just pick a point somewhere, find which quadrant it is in, and then you can determine what the general case is going to be. So we're looking for where we have positive negative and negative positive, and that's in quadrant 2 and in quadrant 4. And so that's going to be answer choice D. Now let's take a look at question number 2. What are the quadrants of the standard xy coordinate plane that contain points on the graph of the equation 2x plus 3y equals 4? So our first step is going to be we need to look at this line 2x plus 3y equals 4. And to be able to graph a line, it's easiest for me, in my opinion, to get this in y equals mx plus b form, and then we can do some graphing using those values. So first I'm going to set up y equals mx plus b, and I rewrite my equation. I bring that 2x over to the right-hand side. Now I'm going to divide through by 3. I have a minus 2/3 x plus 4/3. Now I can take, this is my m value for slope and my y-intercept value, or we call it a lowercase b usually. And if I want to just do a quick plot of that, because I'm needing to find what quadrants that the points on this graph, this line, are going to be in. And so I usually begin with my y-intercept, the b value, that tells me where it crosses the y-axis. And 4/3 is the point 1 1/3. So we're going to be at about this point. And our slope tells us that we're going to go down 2 and over 3. So we have these fractional points. Let me draw out a few things. We have a negative slope. So in general, what that's going to tell us is we're going to be running downward, crossing through this y-intercept. But let's go ahead and do that. So from our y-intercept of 1 1/3, we go down 2. That takes us to a negative 2/3. And then we're going to run over 3. 1, 2, 3. So we're about at this point right here. We're just really eyeballing. And then we want to connect our 2 points and form a line. Again, we're just eyeballing. And so when we look at what quadrants is this line in, well, we see we're in quadrant 1, we're in quadrant 2, we're not in quadrant 3, and then we're going to be in quadrant 4. So we're looking for the answer 1, 2, and 4, which is answer choice K. Now let's take a look at question number 3. What is the intersection of a non-parallel plane A and line B that is contained in a separate plane C? So we get some good information here. We visualize a plane like a sheet of paper. We know a plane, though, goes on and on forever in the direction that it is. This is plane A. And then we have a line B. We are told that they are non-parallel. If they had been parallel, if you can imagine a plane and a line in the same direction, they would never intersect. So we would have an empty space here, an empty set for our solution. But that's not the case because we know it is non-parallel. They are not parallel. And we also are told that line B is in a separate plane C. If it had possibly been in the same plane as A, in this plane, our line B, then the intersection would be the line. But we do not have that because line B is in a separate plane C that intersects, and I'm just going to kind of draw the intersection here. Didn't draw that very well, but this is the plane C, and we have the point that goes through on the other side here. If you can kind of visualize when a line goes through a plane, it's going to intersect at a point, which is answer choice C.